Once again, I welcome back to Education Hub, and those persons who have till today not subscribed, I request you to please subscribe to our channel. And from the last 2 videos, I received a lot of appreciation, and I wish you to thankful to all the persons who have really watched and enjoyed my video. And in addition to this one, or in continues to this one, today I will explain some of the doubts from the 2 videos. Someone asked about them, mainly 2 concepts. First, the additive nature of the charge, and second is the electric field intensity. And I will divide this into 2 parts. First, I will do one video for the additive nature of the charge and another video for the electric field intensity. Now we will discuss about the additive nature of the charge. For this one, first we have to understand from where this concept came into existence. What is the additive nature of charge? See, we know that charges are the basic property of the element, and these charges have some of the properties or some of the natures. Within the nature, what are the first nature of this charge is it is a scalar quantity. It is a scalar quantity. The second nature is we are right, discrete or quantization of charge. The third property is conservation of charge, and fourth property is additive nature of charge, and fifth property is invariance of charge. Let us discuss one by one. You all know what is scalar quantity, because it does not have any vector property. Means what? It is only have the magnitude. That's why it is called the scalar quantity. And second is the discrete or quantization of charge. I already said you what is the quantization of charge. We know that in a material so many particles are there, but we are discussing about the only 3 particles. From these 3 particles, the only charged particles are only 2 particles. One is the electron and one is the proton. And if you take the entire charge of an atom, if you consider the entire charge of an atom, only the charge of the electron and proton is not fully sufficient, but rather the particles which are charged particles present within the atom all are contribute to the charge of an atom. That means what? All the charged particles, what is the charge present within the body, completely we can say is the charge of the body. And this charge is an integral multiple of E. E means what? 1.60218 into 10 to the minus 19 coulomb. It implies that the charge of any atom is the integral multiple of E. This E is nothing but the charge of an electron or proton. That's why this integral multiple implies that this is a discrete nature. Means what? Packet nature. It is not a continuous nature. Means it is not a fractional part, or it is not a continuous part. Rather, it is a packet part, means discrete. Understand? And thirdly, we will see conservation of charge. We know what is in an isolated body. We know what is the isolated body. In an isolated body, there is no charge will enter to this system, or no charge or energy will goes out to the system. In this isolated body, the net charge remains constant, or we can say as well 0. In the same way, if you will see the net charge, if the net charge is 0, means what? There is no creation of a charge or no destruction of a charge. Rather, we can create a charged particle. Once again, I am repeating those things. The discrete or quantization of charge, I already said you. About the conservation of charge, see, In an isolated system, the system, if it say to be isolated, if there's no charge or energy will goes outside the system, or any charge or energy will not enter to the system, means completely isolated. Isolated means what? Separated. You know, from now there is a word isolated is much more rapidly using, but the quantized, quarantine or isolated means what? They're keeping it separate. Means they will not interact with the other environment or outside environment. In the same way, in the conservation of charge, if you take a isolated system, the net charge within the system is zero. Means the total charge which are present within the system is a neutral entity. That means what? There will be no creation of a charge or no destroy of a charge. Rather, we can create a charge particle or we can destroy a charge particle. For this one, I given a simple example of radioactivity, in which uranium can be taken, where uranium is the 90 to 238. When it is disintegrated, it will give the thorium 90, 234 and one alpha particle which is 24. That means what? Here this atomic number is 92, means here 92 electrons are there, 90 electron and 2 electron, they are separated. Means what? It was simply disintegrated. We are disintegrated, means we are separating. In the same way, we can be from the neutron, we can convert into the proton. Means what? We know the neutron is a neutral entity. How can the proton will be a positive charge we are creating? But remember, if you are creating a positive charge, obviously there will be an electron will be created. That means what? This positive and negative will balance as the neutral. That means what? A neutron can be converted into proton. That implies clearly there will be an electron will be generated. In the same way, we can create the charge particle, but we cannot create or destroy the charges. Understand? And third part is the additive nature of the charge. For explaining about the additive nature of the charge, first of all, I will explain about the Gold Leaf Electroscope. What is this Gold Leaf Electroscope? It is an instrument, and this instrument is used for the detection of presence of charge and not detection of presence of current, because galvanometer we are using detection of current, but the detection of presence of charge we are using for the detection of presence of charge can be detection of presence of charge can be happen by the gold leaf electroscope. In the same way, the nature of the charge can be understood by the gold leaf electroscope. First of all, we'll draw the gold leaf electroscope and we'll understand the gold leaf electroscope. Then, how this gold leaf electroscope is helped to explain the additive nature of the charge. Then we'll understand the invariance of charge. We'll understand step by step. This is a gold leaf electroscope. Actually, this gold leaf electroscope is fitted with the cogs. Within this cog, one rod is inserted, and the one end of the rod or the one terminal of the rod is attached with the metallic disc, and the other end of the rod is attached with a pair of gold leaves. And the base of this jar or the base of this jar is conducting base to help the earthing the charges. In the same way, this is the one small basin-like structure where the anhydrous calcium chloride is kept to keep the electroscope free from moisture. Now, this electroscope or the gold leaf electroscope helped to detect the presence of the charge. In addition to this one, this will help for the nature of the charge. First of all, what we will do, simply we will just go through about the additive nature of the charge, or from the nature of the charge we will discuss about the additive nature of the charge. We know the additive nature of the charge. What is the additive nature of the charge? In an extended body, let's take this is an extended body. The total charge in this system or the total charge in this body is the algebraic sum of all the charges present at different regions or different places of this body. Means here one charge, 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 here one charge. These dots I will kept as a symbol for the charges. The total charge is the algebraic sum. Algebraic sum is the addition or subtraction, which will give the for the plus for the positive charge and minus for the negative charge. The total charge in the extended body is the algebraic sum of the charges. Now I will explain by using this gold leaf electroscope. We already know as when the glass rod is rubbed with this silk cloth, the glass rod gains the positive charge. Whereas when amber is rubbed with woolen cloth, the amber gains a negative charge. When the glass rod is kept at the metallic disc, what will happen? This pair of gold leaves will diverge. Why it was diverging? Because when the glass rod is touching to this one, the positive charge will enter by the method of conduction, and these two will become positively charged body. Then what will happen? As both are the positive charge, they will start repelling with each other. When again we will rub to the glass rod with this silk cloth, the charges of the positive charge of the glass rod will increases. When we will touch this one, and again it will diverge more. Why it was diverging more? Because the positive charge in this foil increasing. Again we will do the diverging will be increases. Now what we will do? We will take the amber and rub with the woolen cloth and now touch with this metallic disc. Then what will happen? The divergence will be decreases. Why? Because the negative charge will be distributed within the rod and to the gold leaf. Means it indicates that the positive charge and the negative charge, they are algebraically added with each other. Due to this one, the charges or the positive charge and negative charge was added with each other, and the charges will decreases and the divergence will decreases. It indicates that the charges are added with each other. This is called the additive nature of the charge. Next we will see the invariance of charge. I already told you what is the invariance of charge. When a charge is converted from one inertial frame of reference to the another inertial frame of reference, the charge does not change. That means what? If you are taking the two inertial frame of reference, what is the inertial frame of reference? Means in a frame of reference, the position, time and the velocity or the displacement all are constant. If you take the two inertial frame of reference, both have at constant or equal or uniform velocity with respect to one another. When these will be changes or when the charge we are changing from one inertial frame of reference to the another inertial frame of reference, that charge does not changes. In simply, we can explain in such a way, the charge value does not changes with the speed of the material. Means for this one, I will explain to taking one example. I will take helium and hydrogen. See, in helium, 2 electrons are there. In hydrogen, 1 electron is there. For this one, I will take the 2 hydrogens, means we get the 2 electrons. Whenever we will take this one, hydrogen, okay, and this is the 2 atoms of the hydrogen. where outside one electrons are present in the orbit of the hydrogen. In the same way, in the helium, in one helium, 2 electrons are present in the orbit of the helium. Whenever we know the nuclear charge is much more than the orbital charge, that implies the motion or the energy of the nucleus is 10 to power 6 is the multiple or the product value of 10 to power 6. Means if you take this one, see the structure of this one is the 2a plus, means 2 electrons are present in one nucleus. Here 2 nucleus are present in the 2 different nucleus, but or 2 nuclei. It implies that the energy possessed by this one and energy possessed by this one is different. Whenever we take the speed of these atoms, there will be the neutralization. Whenever we will discuss about the neutralization, there will be so much of difference for these two. It indicates that the energy of this, means what, the H2, and the energy of helium is varies. That means what, with the speed the charge does not changes. It implies that it is an invariance of charge, means what, it will not change whenever the speed will change. It is called the invariance of charge. Thank you.